Good day to you. This is teacher Leland, Alejandro, and we're going to continue lessons about logarithms. We're going to have the properties of logarithms, and problem set will be on the other screen. So let's check it out. Okay. All right, here's the first number. Now you can see the entire problem set. Okay, we can check that out. The entire problem set. Okay, here's the entire problem set, and these are the numbers. So this is about 20 examples. Okay, 20 examples. All right. So for the first part, we have the expansion or expand each logarithm, and then that will be 10 numbers. Then for the second part, we're going to have the condense or compress. Okay, so condense each expression to a single logarithm. So the first is the expansion. Coming from one logarithm expression, you're going to expand it for a particular problem. And then the second part is the reverse of that, the condense. Okay, from a separate terms or logarithms, you're going to compress it into one single equivalent logarithm. And we're going to learn this in detail. All right, so let us have the presentation view, one problem per screen. Here's the first one, expand each logarithm. Okay, so here's the first one. You're presented with the base 2. Okay, you can see the base 2 there. And that's the base 2 there. Okay, and this is supposed to be a ratio. And before we start doing this, we shall try to make use of the properties of logarithms. So if you have a product of two numbers m and base b, then you can expand this into this formula, logarithm of m plus logarithm of n for the same base b, like this. Okay. Now, if you have a quotient like the example here, all right, so for example, if you have logarithm of m over n base b, then this will have to be logarithm of m, that's the expression at the numerator, minus the logarithm of n, the expression at the denominator of the ratio. And this will be for the same base b. Now, if you have an expression with an exponent, so for example, logarithm of mn raised to x, like this, base b, then you can express this like x logarithm of m plus x logarithm of n for the same base b, like that. Okay, so you can remember these properties of logarithms, and we're going to apply this in our examples. Okay, so let's use it in the first number. Let me clear the formulas. All right, let's make use of the given. Now, as you can see, this is a ratio there. So the formula for the ratio is logarithm of m over n base b. We're going to have logarithm of m minus logarithm of n for the same base b there. Now, you can see the exponents there. So that means we're going to use this plus the other one, okay? The other one is when you have exponent there. So logarithm of n to the x base b, you will have to make this x go in front of that, and then logarithm of n base b. There. Okay, so let's apply this one and this one for the given problem. All right, let me start. Okay, here is logarithm 10 to the 3 over 3 to the 4th. And this is for the same base 2. So you can see a ratio here. That means you have here logarithm of 10 to the 3 minus logarithm of 3 to the 4th. So you can see a minus there because it's a ratio here. It's a ratio. So this is for the same base 2. Now you can further simplify putting the 3 in front of the logarithm. So this will now be 3 times logarithm of 10 base 2, and this is minus 4 logarithm of 3 base 2. There. So this is the answer. Okay, this is the answer there. Okay, so we can verify this. Let's verify this from the computer. All right, there's the answer. Okay, you can see it over here. There's the computer's answer, and it matches our answer. All right, so we're done with the first number. Let's continue with the second. Let me proceed to the second. Okay, here's the second. We have logarithm of the product of 12 times 11 squared, the entire quantity raised to 3, base 2. Okay, so we shall simplify this first. Okay, we can express this. We can express this like logarithm of the 12 cube. We can now make use of that raised to the 3 and put it inside the parentheses. This will now be 11 to the 6. There. We can write this expression 12 cube times 11 to the 6. The 6 came from 2 times 3. And the exponent of 12 now is to the 3rd. Now we can consider this as logarithm of a product. So it follows we have logarithm of 12 to the 3 plus, okay, remember if it's a product, it's a plus. So we have logarithm of 11 to the 6. Okay, this is for the same base 2. Okay, simplifying further, all right, we can move the 3 in front. So we have 3 logarithm of 12 base 2 plus, we can now put the 6 in front, 6 times logarithm of 11 base 2. And here's the answer. There. And we can check it out. There. Okay, so we have the answer over here. Let's remove our box there so we can see it clearly. Okay, here's the answer. There, okay. You can see it and it's equivalent to our answer. So over here. Okay, so 3 logarithm 12 base 2 plus 6 times logarithm of 11 base 2. So exactly what we have made. Okay, let's have the third. Let's continue with the third. Let me remove my writings and let's remove the answer. Let's proceed to number 3. Okay, here's number 3. Logarithm of the expression 5 times 7 to the 5, the entire quantity raised to 3. So what we need to do here is distribute the 3. We can distribute the 3 there like that, just like in the previous problem. So that this will be a logarithm of 5 to the 3rd and multiplied by 7 Okay, the 5 and the 3 will be 15. Remember the law of exponents, so that will be 3 times 5 by 15. This is now the entire expression, base 6. Okay, so this is a product. You can see the dot there. It's a product. This is a product. So this is now equivalent to logarithm 5 to the 3 plus logarithm 7 to the 15. And these are both base 6 there. And then all we need to do now is put the exponents 3 and 15 in front of the logarithms. So this will now be 3 times logarithm of 5 plus 15 logarithm of 7. And these are both base 6 there. And this is the answer, okay? There. And so we can verify the answer. Okay, so let's verify the answer. Okay, we shall rewrite it at a lower part so we can see the answer clearly. Okay, let me remove our answer there so that we can. All right, let's put it at the bottom. Okay, let's put it at the bottom. We cannot see the answer as shown by the computer. All right, let's put it here. Logarithm 5 and the 3 is here. This is plus, we have 15 logarithm of 7, and these are both 6. Yeah, okay. Now we can display the answer. All right, we can display the answer. There. Okay, so we were able to display it clearly, and it's over here. And it's exactly what we arrived at, okay? So 3 logarithm 5 base 6 plus 15 logarithm of 7 base 6. All right, so that goes to our third. Let's proceed to our fourth example. Okay, I hope you're learning how to expand it given one logarithm like this. All right, let's have the next. We're doing number 4 now. All right, here's number 4. Logarithm of the quantity 7 times the square root of 11 times 2. And this is for base 6. Okay, what we need to do first is simplify the expression in front of the logarithm. So we have here logarithm base 6. We can express this like 7 times the square root means 11 raised to 1/2. There. Times 2 raised to 1/2. There. And here is our expression now. Remember, the square root, that's exponent to the 1/2. Okay? So we can use the radicand's 11 raised to 1/2 and the other factor 2 raised to 1/2. And so we now have the product of 7 times 11 raised to 1/2 times 2 raised to 1/2. Okay? All right. How did we get that? All right, let me explain that. The square root of 11 times 2 is equal to square root of 11 times square root of 2. And this is equal to 11 to the 1/2 times 2 to the 1/2. There. That's the meaning of what we just made. Okay. All right. So you can actually take that from algebra, basic algebra. The square root of AB is equal to square root of A times the square root of B. There. And this means A to the 1/2 times B to the 1/2. There. Okay. I hope you still remember these laws in exponents. Now we can continue with our number 4. This can now be written as sum because these are all products. Okay, these are all products. So this is logarithm of 7 plus logarithm of 11 to the 1/2 plus logarithm of 2 to the 1/2. These are all base 6. There. Okay, let's remove the other writings at the bottom. You have seen that part already. Let's erase it. Okay, erase there. All right. Here comes the next part. This will now be logarithm 7 base 6. Now you can put the 1/2 in front now for the second term. Plus 1/2 times logarithm of 11 base 6. Also plus 1/2 logarithm of 2 base 6. There. Okay. And then that's it. We can erase the other things at the bottom. And we can rewrite this, okay? The 1/2 that you see in front of the log, okay, this means the same as this. Logarithm 7 base 6. You can also write it logarithm 11 base 6 over 2. You can also write it this way. Plus logarithm of 2 base 6 over 2. You can also write it this way. Okay? All right. So we can check on the answers. Check the answers. All right. Let's check. All right. Let me erase the line that we wrote over here so we can see the answer clearly. Okay. Our final answer is the last line. Okay. There. So we have the same answer as the computer. Okay. You can inspect that. Okay. All right. And that goes to our number 4. Let's have our number 5. Okay. All right. So I hope you were able to get that. Okay. All right. I hope you were able to get that before we continue to the next number. Let's continue with number 5. Okay. I just gave you time to see the answer. All right, let's continue with number 5. Here's number 5. Logarithm of the expression 7 times 5 times 2 squared, base 4. So the dots that you see there are supposed to be products. Okay, those dots means multiplying. So we can use the formula for a product that will include plus of logarithms, addition of logarithms. So this will now be written logarithm of 7 plus logarithm of 5 plus logarithm of 2 squared. There. Okay, and these are all base 4. And then we can simplify the last term. Okay, we can simplify the last term. The last term is logarithm of 2. Then we will have a number 2 over there. And this is base 4. And of course, we will just rewrite the logarithm of 5 base 4 and added to logarithm of 7 base 4. There. That should be the final expansion. All right, so we can verify the answer. Okay, here's the answer. It's comparable to our own answer. Okay, the same thing. All right, there. All right, so that goes to our number 5. Let's proceed to number 6. So you see our answer is exactly what the computer has there. All right, let's continue. Let's continue with the next. All right, let's have the next one. We're doing number 6 now. Here's number 6. Okay, here's number 6. All right. We have the expression a times b times c to the 6. And this one has the base 6 also. So again, you have the dots there. That means this is a product. And we're using letters now instead of numbers. So this will be, let's change color to blue, okay? Let's change color to blue. All right, so this will now be logarithm, okay? Logarithm of a plus logarithm of b plus logarithm of c to the 6. There, logarithm of c to the 6. Okay, so this will be of the same base 6 here. Okay, base 6. All right. And so we can further simplify the last or third term. This can be plus logarithm of c, and this is base 6. And you must have the, before the plus, we must have the 6 in front, and then this will be plus, and then plus logarithm of b base 6 and logarithm of a base 6, and this is our answer. Okay, so let's verify. There, I wrote it in blue so that the red answer is different in color. Okay, so it don't confuse us. All right, so here's the answer, and we're exactly correct. Okay, you can compare the blue and the red answer, and we're done. All right, let's have the next. Let's have number 7. Let's have number 7 here. Okay, here's number 7. Logarithm of the expression x times y to the fourth, the entire quantity raised to the 4. Okay, all right. So this will now be logarithm of x to the fourth. We can spread the 4 there. Okay, we can spread the 4, x to the fourth, and then y to the 16. There. Okay, that's the equivalent of distributing the 4, the exponent for inside. Okay, we multiply 4. Remember, this is x to the 1. Okay, so that means 1 times 4. That's why we have x to the fourth. And then we have y to the fourth. Okay, raised to the 4. That means we will have to multiply with 4 by 4. So we have 16. Now this is equivalent to logarithm of x to the fourth plus logarithm of y to the 16. There. And we shall now put the exponents in front of the logarithms. So this will just be, okay, this will be equal to logarithm x, and the 4 goes here, plus logarithm of y, and the 16 goes there in front, there. And this is it. This is the simplified version. Okay, this is the simplified equivalent there. Okay, all right, then we can verify the answer there. So you can see 4 times logarithm of x plus 16 logarithm of y. So that should be our answer for number 7. Okay, so next we'll be doing number 8. Here's number 8. All right. Expand each logarithm, and we have logarithm of w squared cube root of u. That means w squared times cube root of u. Okay, w squared times cube root of u. So we can see this as a product of two expressions, product of w squared and cube root. So we can write this like logarithm of w squared, and that cube root is 1/3. That means this is times u raised to 1/3. There. The index number becomes a denominator of the fractional exponent. And so we can express this logarithm of w squared plus logarithm of u to the 1/3. There. And this can be written so that the 2 goes in front times logarithm of the w plus the 1/3 goes in front, and we have logarithm of u there. Now 1/3, you can rewrite this like over 3, like that, and then the logarithm of u up here, like that. And so this first term here is just 2 times logarithm of w there. And this is our answer. Okay, and we shall see the equivalent of this there. You can see the answer right here. There. Okay, 2 times logarithm of w plus 1/3 of logarithm of u. That goes to our number 8. Let's continue with the next number, number 9. Okay, let's continue with number 9. All right, here's number 9. The logarithm of the quantity x to the 6 times y. The entire expression raised to 5. Okay, so first we will distribute the exponent 5 inside. So that this will be logarithm to the base 5. Okay, that x to the 6 becomes x to the 30. There. And the y will be raised to the 5. There. Okay, go back to the law of exponents if you did not get this part. All right, so you simply distribute. There's a 1 here, of course. That's y to the 1, and then this is 5 times 1, and this is 5 times 6. Okay, that's why we have x to the 30 and y to the 5. Now we can now expand this using this product, of course. Okay, this is now logarithm x to the 30 plus logarithm of y to the 5. And these are both base 5. Okay, there. And then one more line, and we have the final answer. Now, this time we're going to make use of the property, the third property with the exponent. Okay, so this will be logarithm of a power. Okay, so if you're going to be, if you want to be reminded about the formula, this is the formula. Logarithm of m to the x base b is equal to x times logarithm of m base b. There. Okay, this is what we're using. Okay, and so the final answer here will just be 30 times logarithm of x plus 5 times logarithm of y base 5 there. And so the answer is right here. Okay, that's the answer. And we shall verify it after a little while over here. Okay, you can see the answer right here using the red color answer there. So 30 logarithm of x plus 5 logarithm of y base 5. Oh, of course, this is base 5. The base number there. Yes. Okay. We have it right there up to the first expression there. Okay. So that's 30 logarithm of x base 5 plus 5 logarithm of y base 5. All right. Now, if you don't see any base number, that is, of course, base 10. Okay. If you don't see any base 5. For example, if you don't see this, if there is no base number there, that means base 10. Okay, so we have to be very specific there. So this is given base 5, so the base 5 must be written there. All right, so that's it. We will have the next, we will have the number 10. Let's have number 10. Okay, let's have the next number. This is number 10. Okay, this is a ratio. Okay, it's a ratio, and you can see the division symbol there. Okay, the division symbol there. For a ratio, we will not use plus. Instead, we will use a minus. So this can be expressed logarithm of x cubed minus logarithm of y to the 4th. Okay, base 8, base 8 there. And so we still have to simplify this. The x cubed will have the 3 in front of it. So this will be 3 times logarithm of x. And then this will be minus 4 times logarithm of y. And these are both base 8 there. Okay, and so this is the final expansion. Okay, so remember, if it's divide, it will be a minus there instead of plus, and that will help us remember the formula. Okay, and let's check the answer. there is the answer there. So you have 3 logarithm of x base 8 minus 4 logarithm of y base 8. Exactly what we have over here. Let's do number 11 now. Number 11. Okay, number 11. Okay, let's have number 11. Here's number 11. Condense each expression to a single logarithm. This time it's the reverse process. Okay, it's the reverse process. Let us try to make the displayed problem smaller so that we will have more space to write on. Okay, so let us shrink it. Let's use this. Let's shrink it. Okay, there. Okay, now we have more space. Will that be small enough? That will be too small. Okay, that will be it. Okay, we have more space to write on. All right, condense each expression to a single logarithm. Okay, you can see this given expression. These are all divided by 2. Okay, and this means 1/2. Okay, so the way to solve this, we simply put the 1/2 in front. So we have 1/2 logarithm of 12 base 4. Okay, I'll try to write in smaller figures. So then the second is 1/2 times logarithm of 5 base 4, and then plus logarithm, we put the 1/2 first, and then logarithm of 11 base 4 there. Okay, so you see there's a 1/2 in front of it, okay, of each term. So dividing it by 2 is the same as multiplying it by 1/2. So now we can put that 1/2 as exponent of the 12, exponent of the 5, and exponent of the 11. Okay, so that this will be like this. We have here logarithm of 12 to the 1/2 plus logarithm of 5 to the 1/2 plus logarithm of 11 to the 1/2. There. These are all base 4. These are all base 4. There. Okay. Otherwise, if you don't have if you have different bases, you cannot express this as a single logarithm. Okay. All right. So these are all in base 4, so we can compress this or condense it to a single logarithm. So those 1/2 means all of them is expressed as raised to the power 1/2. So we can now multiply all this. Okay, remember we're doing the reverse process. This means logarithm of 12 to the 1/2 times 5 to the 1/2 and times 11 to the 1/2. There. Okay, and this is just base 4. There. Okay, we can also write this now as logarithm, since these numbers 12, 5, and 11 are all raised to the 1/2, then that means we can write this 12 times 5 times 11, and the product of this raised to 1/2. There, base 4. Okay, and then we can actually multiply 12 times 5 times 11. Okay, and how much is that? Okay, 12 times 5 is 60, and 60 times 11, that looks like 660. Okay, 660. Let's do it over here. 12 times 5, that's a 60. Okay, times 11, that will be a 60 and a 60, and that is actually that will be something like 660 there. So we can write this logarithm of 660, okay, raised to 1/2 is square root. That means we can write it this way. Okay, and this will be base 4. There, and that's the answer. There. Okay, so that is logarithm of the square root of 660 base 4. And how about the answer from the computer? Let's remove our multiplication here. Okay, what's the answer? All right, there's the answer. Okay, logarithm of the square root of 660 base 4. And so we are correct. All right, let's have the next number, number 12. Let me clear the screen. All right, let's have the next number 12. Okay, here's the next one. Condense each expression to a single logarithm. Okay, express it. All right, so we can check on the given 6 times logarithm of 5 minus 24 times logarithm of 3. And we can see it clearly, it's a minus. It's a minus there. So that means we should have a ratio here. Okay, a ratio. So this will proceed like logarithm. We can now put the 6 as exponent of 5 there. Okay, and we have here minus, we will use now the 24 exponent of the 3 there. Okay, all right, and so we can now proceed to the ratio. All right, single logarithm. Okay, as you can see, there's no base number. There's no base number. There's no base number here. Okay, so that means this is base 10. Okay, this is base 10. All right, so we can express this as a ratio. We will now use the 5 to the 6 here and 3 to the 24 right there. And that's it. Okay, single logarithm. All right, in some cases they put a parenthesis there like that. Okay, all right, and so we can express the answer 5 to the 6, 3 to the 24. Okay, either of this is the answer. Okay, same thing. All right, so that should be it, and let's check the answer. All right, let me remove that arrow. Okay, here's the answer there. Okay, so the computer does not require the parentheses, so it's this one, 5 to the 6 and 3 to the 24. All right, so that goes to our number 12. Let's continue with the number 13. Let's have number 13. Okay, let's have number 13. We have here added logarithms. So we have logarithm of 7 plus logarithm of 5 plus logarithm of 6, and these are all divided by 3. Okay, all right, so these are all plus. You can see here a plus, and that means we will have a product, okay, not a ratio. Okay, so this will be a product. So we can rewrite this 1/3 logarithm of 7 base 4 plus 1/3 logarithm of 5 base 4 plus 1/3 logarithm of 6 base 4. There. Okay, so the 1/3 now in front of these logarithms will become exponents of the 7, the 5, and the 6. So to continue, we have logarithm 7 to the 1/3 base 4 plus logarithm of 5 to the 1/3 base 4 plus logarithm of 6 to the 1/3 base 4. And then we can now compress this or condense it to one single logarithm. Okay, one single logarithm. So this will just be logarithm of 7 to the 1/3 times 5 to the 1/3 times 6 to the 1/3. And these are all base 4. So this is now one single logarithm. And these are all exponent to the 1/3. So we can just write it one exponent 1/3. So we have here logarithm 7 times 5 times 6, and these are all raised to the 1/3. Okay, and base 4. How about the product of 7 times 5 times 6? 5 times 6, that's a 30. Times 7, okay, times 7, that's 210. And 1/3 means cube root, okay? So we will have to write this cube root of 210. And this is logarithm of cube root of 210, base 4. There. And this must be our required answer, okay? So you see, this is now one single logarithm, and we can now verify the answer. Okay, let's check. All right, it's over there. Logarithm of cube root of 210. It's over here. Logarithm of cube root of 210 base 4. Okay, so this must be correct. And just remember how we did it. Okay, so you'll be able to learn how to expand or condense. Okay, let's have the next number 14. Here's number 14. And an indication of a minus, that means this must be a ratio. Okay, 4 times logarithm of 6 base 5 minus 2 times logarithm of 7 base 5. So we know what to do when it's a minus. Okay, so we can write this logarithm. Let's put the 4 exponent of 6 there, and this will still be base 5. Okay, and then we have minus, let's use the 2 now, exponent of the 7 there, still base 5 there. Okay, all right, so logarithm of 6 to the 4 minus logarithm of 7 squared, base 5. Okay, so this will now be expressed as a ratio. Okay, we can now express this as 1 logarithm of 6 to the 4 divided by 7 squared there, base 5. And this must be it. Okay, all right, and let's verify the answer. It's over here. You can see the answer here, red numbers, and exactly what we have over here. So that goes to our number 14. Let's continue with the next number 15. I hope you're getting the way to do it. So let's have the next. Let's have number 15. Here's number 15. Condense each expression to a single logarithm. 9 times logarithm of 7 base 3 minus 3 times logarithm of 11 base 3. Again, you have a minus here. You can see a minus, an indication of a ratio. So that means we can write this logarithm 7 to the 9 there, base 3. Okay, that's for the first term. Then we continue with the minus logarithm of 11 base 3. Okay, and this is also base 3 there. Okay, now we can now compress this to one single logarithm. The logarithm of 7 to the 9 over 11 to the 3. And these are both of these coming from base 3, so this must be base 3 there. And so that's it. And this is the answer. Let's verify. And you can see the red numbered answer. It's over there. Exactly what we have right here. And so I hope you learned from this number 15. We shall continue with the next number. This will be up to 20. All right, so we still have 5 more numbers. Okay, condense. All right, we have all sum. These are all sum there. Okay, so that means this is logarithm of x over 2 plus logarithm of y over 2 plus logarithm of z over 2. And we can actually put the 1/2 in front. So this will just be 1/2 logarithm of x base 8 plus 1/2 logarithm of y base 8, and we have 1/2 logarithm of z base 8. That's letter z. Okay. All right. So we can now use the 1/2 as exponent of the letters. So this is now logarithm of x to the 1/2 plus logarithm of y to the 1/2. Okay, that's logarithm there, plus logarithm of z to the 1/2. These are all base 8. Okay, these are all base 8. And so we can now condense it to one logarithm expression, logarithm of x 1/2 times y 1/2 times z 1/2. And these are all base 8. And so we can write this as x, y, z raised to 1/2. So this is logarithm of x, y, z raised to 1/2 base 8. And the final expression will be 1/2 means square root. So this is logarithm base 8 square root of x, y, z. Okay. All right. In any order. X times y times z, z times x times y. It doesn't matter. Okay. Uh, commutative property of multiplication works there. Okay. All right. So x times y times z, that will be square root. All right. Let's check the answer. All right. There. And here's the answer of the computer. All right. The computer choose to write it zyx. Okay. It means the same thing, xyz or zyx. It's product. Okay. All right. So that will be for number 16. Let's proceed to number 17. Okay. All right. Let's go to number 17 after I remove the red number there. Okay. Here's number 17. We have a minus, an indication of a ratio. This will proceed logarithm of a to the 5. Okay. There's a number 5 in front of the logarithm, so that will become a to the 5, base 4. And this is minus logarithm of b to the 20. There, b to the 20 base 4. Okay. All right. So that will still be something you can see from logarithm of power. Okay. Logarithm of power. So the number in front become exponent of the expression in front of the log. Okay. Just in case you're wondering how it's done, that came from this. Okay. Logarithm of m to the x base b, that's equal to x times logarithm of m base b. Okay, don't forget this. Okay, there. It came from this expression. All right, so we shall continue with the ratio of this. So this is now written logarithm a to the 5 over b to the 20. There, base 4. And that looks like the final answer. Okay, that looks like the final answer. And so let's see the answer. There. So we have the answer exactly what we have over here. Okay. All right. So that goes to our number 17. We will continue with the next numbers. Let's proceed to number 18. All right. Here's number 18. Here's number 18. A very simple addition of logarithms here. Okay. So we can read the problem. 6 times logarithm of x base 4 plus 3 times logarithm of y base 4. So you can write this right away as logarithm of x to the 6 plus logarithm of y to the third or y to the 3. And these are both base 4. Okay. If it's a plus, then x to the 6 will be multiplied by y to the third. So this will be a logarithm of x to the 6, y to the third, base 4. Yeah. And that's it. This will be the expression, all right? So sometimes they put a parenthesis there. I wonder if this one has it, okay? All right, let's check it out. Okay, there, all right. Logarithm, the answer of the computer is written such a way that y is written first, but it means the same thing, okay? Commutative property of multiplication. So y to the third times x to the 6 is the same as x to the 6 times y to the third. So this is also correct, okay? So what we have right here is also correct. Number 19, let's have number 19. Okay, number 19. All right, let's have number 19. Here's number 19. 8 times logarithm of a plus 2 times logarithm of b. Condense, okay? So we'll have to condense it. You can start right away as logarithm of a to the 8 plus logarithm of b squared, and these are both base 5 there, okay, base 5. All right, so since this is addition, we can express a to the 8 times b squared, logarithm of a to the 8 times b squared, base 5, okay, and we can put parentheses there like that. That will be the condensed single logarithm, and we can verify the answer there. All right. Again, the computer's answer is written such a way that B comes first before A, and it doesn't make our answer different. Okay, it's the same. Okay. All right. Remember commutative property of multiplication. Okay. So B squared A to the 8 is also equal to A to the 8 B squared. Okay. All right. So this is also correct. And for our last number, let's see our last number. All right. Okay, this is the last number, number 20, and nothing follows. All right, so this is the last number. Let's condense it. Again, these are all addition. Okay, and so we can start with logarithm of a times b times c squared. Okay, let me show you that. Logarithm of a base 2 plus logarithm of b base 2 plus, you can see a number 2 there, okay, in front of the log. So that becomes exponent of the c. That becomes c squared, like that, and these are all base 2. And then we can now make it just one single logarithm by multiplying a, b, and c squared. So this is now logarithm of a, b, and c squared there, and base 2. All right, that's it. And this must be the right answer. All right. Again, the answer of the computer is BAC squared. And our answer is alphabetized ABC squared. All right. So it doesn't matter. Okay. This is the same as the computer's answer. Okay. All right. Remember, just remember, B times A times C squared is also equal to A times B times C squared. Okay, commutative property of multiplication. All right. Okay, that will be all for our properties of logarithms. I hope you were able to learn expansion and condensation of logarithmic expressions. All right, so that will be all, and I hope you'll do your Genvity activity, and that will be for this hour. And see you later. Bye bye.